Dear student, welcome to the second session of first unit power electronics subject. In this session, we'll be discussing both power transistors, means what is meant by power transistors, and the type of the power transistors, and about BJT introduction, and the working of BJT as a switch, and switching character of a BJT, and applications of BJT. As already in the previous semesters you have studied about transistor, means what is meant by transistor, but in this session we will be discussing about power transistors. As you know, transistor means it consists of two words, that is a transfer resistor. Means the operation or the function of transistor is equivalent to transferring the input resistance to the output side. But practically it will not transfer the resistance, but the output current is controlled by varying the input current. It means it is as good as varying the output resistance by varying the input resistance, because the name transistors. Now power transistors means a transistors which can handle large amount of current and can operate at higher voltage, or it can handle large amount of power. That type of device are called as transistors. The main features of transistors are they are rated for higher voltage and higher current, and the transistors can be turned on when an input signal is applied, and they will turn off when the input signal is removed. Transistors have high switching speed but low voltage, low current rating than that of a thyristors. Hence transistors are mainly used for low power applications, but where the switching speed is required at a higher value as compared to the thyristors. This slide you can observe the appearance or the structure of a power transistors. They are available in different models, different structures, depending upon the power handling capacity and the type of the mounting and the type of the cooling facility provided to the transistors. The transistors will have different models, but the functions of all transistors will be similar. Mainly in a power electronics, transistors are mainly used as a switching device, means switch on and switch off operation. Now we shall discuss about types of transistors. One is a bipolar junction transistor or a BJT, and second one is a metal oxide semiconductor field effect transistor, that is MOSFET, and insulated gate bipolar transistor, that is a IGBT. Bipolar junction transistor means mainly here in this device the current carrying will be due to the flow of two types of carriers, that is electrons and holes, hence a bipolar. And between alternate layers there is a junction, so the word junction, and its operation will be, as I explained in the earlier, to transfer the resistance, or it is a transistor. So that is this device is called a bipolar junction transistor. BJT will have three layers, that is in between two N layers, one P layer is provided. That transistor is called as a NPN transistor. If a N layer is provided between two P layers, then it is called as a PNP transistors. The function and the operation and the characteristic of both the NPN transistor and the PNP transistors are almost similar, hence they can be used for similar applications. The transistors, it has a three layers and it has a three terminals also. One is a emitter, other is a collector, and third one is a base. The function of emitter to inject or to supply majority carriers into the layer, and the function of collector to collect the carriers coming from the emitter through base layer. So whatever the carrier supplied by the emitter will be collected by the collector, and the function of base which will regulate the flow of carriers from emitter to the collector. So it will act like a support to the movement of the carriers, the transistors. The symbol of PNP and NPN transistors are as shown in the figure, and the layer diagram will be as shown. And practically when the fabricating, the size of the collector layer will be larger than the emitter and a base, but in case of a base layer will be the smallest one among all the three layers. Emitter will have a high level of doping so as to supply the carriers, so highest level of doping will be provided to the emitter level than that of a collector and a base. Base is a lightly doped, only about 2 to 5% of the that of a emitter or collector. Transistor is a current control device, means the output current can be controlled by varying the input current, that is a base current usually. So in almost all applications, when the transistor is connected in the circuit, it can be connected in 3 different configurations, that is a common base configuration, common emitter configuration, and a common collector configuration. So for most of the applications, common emitter configuration will be used. As in case of a transistor, 3 layers are there, so 2 junctions will be there. For normal operation, that is the junctions are referred as a collector base junction and a base emitter junction. For normal operation, the base emitter junction will be usually forward bias and collector base junction will be reverse bias. But in case when the transistor or a power transistor used as a switching device, when the transistor in off state, base emitter junction will be reverse bias as well as base collector junction also reverse bias. But when the transistor is set as a switched on or when it is in on state, both base emitter junction and collector base junction both will be in a forward bias condition. In this slide, you can observe the layer diagram or structure diagram of a power BJT. So the layer diagram is somewhat different from the normal signal transistors. That is, in this power BJT, there is one extra layer will be provided, that is a N minus layer is provided above the N plus layer, that is above the substrate, and that is in between outer N layer and inner P layer. So that layer is called a drift region. The main purpose of this providing this extra layer in the power transistor, which is responsible for the high breakdown voltage of the transistor, because for power transistors it has to operate at higher voltage, so it has to withstand higher voltage, higher reverse voltage. So because of that reason, to withstand higher voltage, one extra layer is provided, that is a N minus layer is provided in case of NPN transistor, and that layer is called a drift region. BJT can be used as a switch, means to perform on and off operation. Even transistor can be used as a amplifying device to increase the strength of a low level signal to the higher level signal. But in most of the industrial applications, power BJTs are mainly used as a only switching device. So to study the switching operation of the transistor, we shall consider the circuit shown in the slide. So in case of in the circuit is shown that there is two loops are there, base emitter loop and a collector emitter loop. In the base emitter loop, the input signal is applied, a controlling signal is applied in series with a resistor, and in a collector emitter loop there is one supply VCC along with there is a current limiting resistance RC, which will act like a load resistance. As a base current of the transistor is varied, there is a change in the collector current. So we shall discuss about that on how the collector current or a collector emitter voltage will vary with a base current or a input voltage, that is a base emitter voltage. If you want increase the base current, there is for certain time period the collector emitter voltage will not change its value, but as the base current increase above higher and higher value, base voltage also increase, means both base and emitter voltage will increase, that is collector emitter voltage start decreasing as collector current increases. And when the collector current does not change with a small value of base current, that is called as a cutoff region. But as the collector current start increases, as the base current increases, decreasing the collector emitter voltage up to certain minimum value, then that operation or that state of a transistor is called as a active region, or the transistor working as a amplifier. If the base current is continuously increased above certain maximum base current, then there is a continuous decrease of a collector emitter voltage. When the collector emitter voltage decrease below base emitter voltage, collector base junction also gets forward bias, and a heavy current will flow through the transistor, and the transistor is said to be operating in the saturation region or operating in a on state. So variation of the output voltage, that is the collector emitter voltage, with respect to the input voltage or input current is as shown in the graph. Up to certain input voltage or up to certain base current, the collector emitter voltage decrease will be very small, and that is a cutoff region. And when the base current increase above certain value, as the base current increases, collector emitter voltage will decrease almost linearly, and that is active region. And when the base current increase above certain maximum value, the collector emitter voltage comes to the minimum value, and that is a saturation region. It means the BJT or power BJT will operate in three different states, that is cutoff region, active region, and a saturation region. But practically power BJTs are used for the switching operations, hence a power transistor will operate, or power BJT will operate only in two states, that is a cutoff state and a saturation state. Now we shall discuss the switching character of a BJT, means when the transistor changes its state from off state to on state and on state to off state, what exactly changes, what change will occurs internally in the transistor, that we shall discuss with a waveform which are as shown in this slide. When the base current is increased to its value, certain maximum value, the base emitter voltage also increases, and a base current and base emitter voltage remains maintained at a constant value. But at the same instant, collector current will not flow, or collector emitter voltage remains at a equal to the VCC up to for certain time, that is the delay time. So this delay time is required to charge the internal capacitance. It takes certain time, for till that there will not be any collector current. But when the internal capacitor charges, then gradually collector emitter current will increase and collector emitter voltage will decrease gradually. After certain time, that is a TR time, after a interval TR, the collector current reaches its maximum value and remains at a steady value. At that instant, collector emitter voltage comes to the minimum value and remains at a minimum value, and now the transistor is said to be it is in on state. During switch off also, when the base current is removed by interrupting the base emitter voltage, there will not be change in the collector current. Collector current will continue to flow with the same magnitude for certain time period, that is a TS. That is TS means it is a storage time. Till that charge, excess stored charges discharges, collector current does not change, it remains in with the same magnitude even there is no base current. After removal of the stored charges, then gradually collector current will decrease and collector emitter voltage will decrease. After certain time, that is a TF, the complete collector current will reduce to minimum value or 0, and the collector emitter voltage reaches to maximum value, that is equal to VCC, and now the transistor is said to be switched off. So this variation of a collector current, collector emitter voltage, base current, base emitter voltage as shown in the waveform. Power BJTs are used for number of applications, that is especially industrial applications. The power BJT can be used to convert DC to DC, that is fixed DC can be converted into variable DC, which is required for number of industrial applications, like to control the speed of a DC motor, variable DC voltage required, or else to charge the battery, some variable DC voltage required, or in a UPS or in a aeroplanes to supply the inverter, a variable DC voltage may be required, or even in a electroplating or electrochemical processes, some variable DC voltage may be required. So to convert a fixed DC into variable DC, BJT can be used efficiently. Similarly, the BJT can be used, power BJT can be used to convert DC to AC, that is known as the inverters. Means the available fixed DC can be converted into variable AC. So variable AC means the output AC voltage can be varied, as well as the output AC frequency can be changed, because some AC loads required a variable AC voltage or a variable AC frequency may be required. For such application, very easily DC can be converted into AC by using a power semiconductor device like a bipolar junction transistors. So this variable AC may be required, for example, in industrial application to control the speed of a induction motor or synchronous motor or any AC motors, because as you know, speed of the AC motor like induction motor or any other motors can be controlled very easily by varying the frequency. So the frequency can be very easy, conveniently or very easily it can be varied by converting DC to AC with a desirable frequency. And some applications required AC voltage, variable voltage also required. So here also by varying the DC on and off time, the output AC voltage can be varied, frequency can be varied, hence that available variable AC voltage can be given to the required AC loads. The BJT power BJT can be also be used in a circuit to control the temperature of a furnaces or ovens. In industrial applications, the temperature of a furnace may be varied by varying the applied voltage or a frequency, because in an induction furnaces mainly the amount of heat developed will be depends upon the frequency of the AC supply given to the system. So where the variable frequency may be required, so for such applications BJT can be used very easily, the frequency can be controlled, and hence the furnace temperature can be very accurately and easily controlled. Similarly, BJT can be used in a power supply systems like SMPS or in other supply systems where the regulated voltage may be required, AC voltage or DC voltage. For such applications, BJT can be very easily used. And BJT can be also be used as even a simple static switch instead of a mechanical switch or electromechanical switch. Static switch transistor can be used as a static switch or static circuit breaker, because the size of the power BJT will be very small as compared to the electromechanical switches or electromagnetic switches or electromagnetic or electromechanical circuit breakers. The compact size, maintenance free, because of that applications BJT can be very easily can be used. And even in some applications the power BJT can be used as a power amplifier circuit where the high volume or the sound signals are required. For such applications the power transistors can be very easily used. Now we shall discuss about a multiple choice questions on BJT with their answers. So as you discussed now, so far we have discussed about the BJT or a power BJT. I'll ask a questions and you can try to answer. There will be options for the questions. So that is a multiple choice questions and the answers we have discussed. Which is true for a BJT? Which is true for a BJT? The first option is current controlled switching device, current controlled amplifying device, voltage controlled switching device, voltage controlled amplifying device. And the answers here, options given are both 1 and 3, B will be 1 and 4, and 2 and 4, and 1 and 2. Can you answer? The correct answer is a D, that is both 1 and 2 options are correct. That is, 1 means that the BJT is a current controlled switching device and it is a current controlled amplifying device also. So that is the correct answer. Now second question is, collector of a BJT is the question. Collector of a BJT is dash. Means options are heavily doped and the biggest in size, moderated doped and the biggest in size, heavily doped and a smallest in size, moderated doped and a smallest in size. Anybody? So the correct answer is B, that is a moderated doped and a larger in size. The third multiple choice question is a BJT used as a switch operates in 3 regions. That is, options are cutoff and saturation region, active and cutoff region, active, cutoff and saturation region, active and saturation region. The correct answer is A. So power BJT used when it is used as a switch, it is operate in a cutoff and a saturation region. So next fourth question is when BJT is in cutoff region, so which option is correct among all these 4 options at A, B, C, D? Any answer? The correct answer is a B, that is IB 0, IC 0, VC is equal to VCC, base, that is base emitter junction and collector base junctions both are reverse biased. So next question is, that is fifth question is when BJT is in saturation region, which option is correct among these four options? Yes, the correct answer is A, that is IB is maximum, IC is maximum, VCE is equal to 0, and base emitter junction and collector base junction both are forward biased. The next question is, in power electronics, BJT is used as A amplifier, B switch, C either switch or amplifier, D as oscillator. Yes, correct answer is a B, that is it is used as a switch. So next question, turn on time of BJT includes delay time and fall time, storage time and rise time, delay time and rise time, storage time and fall time. The correct answer is a C, that is a delay time and rise time. So next question is, when the base current is applied, the transistor does not turn on instantly because of, the options are A, internal capacitance, B, junction resistance, C, both resistance and capacitance, D, none of these. The correct answer is A, that is because of the internal capacitance, it will not start instantly. So now next question is, in BJT as a switch during fault time, which option is true among these four options A, B, C, D? Yes, any answer? The correct answer is a B, that is IC decreases to 0 and collector voltage increase to VCC. So next question, that is the last and the 10th question, choose the correct statement for BJT, that is A, B, C, D. Four options are there. Which option is correct? The correct option is D, that is low input impedance, low on state conductance loss and high switching losses. So this is the correct answer. So if you have any doubts or any questions other than these questions about the power BJT or any other this power semiconductor device or power semiconductor devices, you can ask. Okay, thank you. We shall see in the next session. Thank you very much.